today, yeah? Sorry, question? Okay, today we're going to be going over chapter 10.1 and 10.2. And then also Tuesday, so only 5 days from now, you have 10.1 due. But it's not super hard. We're going to go over today. I think you guys have been in fine shape. And then also project part 5, you can turn that in late for full credit by Tuesday, and just email it to me. That's fine. And then next Thursday, you'll have Connect Math 10.2 today, which we're also going to which we're going to finish up today. So next Tuesday, you'll have 10.2, and next Thursday, next Tuesday 10.1, and next Thursday 10.2. Those will be the two things we're covering today. Exam 4 is rolled into the final. So the final is going to be 30% on chapters 10 and 11, because I just put it back in there rather than to waste a day testing when we could just be reviewing for the exam. I just threw it in there so it's all incorporated into the final, so that's why it's weighted more in the final, when it really is only worth like half of the other exams. And then the rest of them are going to be 20% on exam 1, 20% on exam 2, and then 25% on exam 3. So this is your makeup, which means that you really, you want to make sure you really get this exam, this exam 4 stuff, the chapters 10 and 11 down well. 10 and 11 are not difficult. They're not hard chapters, especially the way I'm going to cover it. I'm going to cover them very lightly, just superficially, and we're going to use a lot of the calculated functions just to do it. So it's not super hard, but if you don't come to class, then it's going to be harder because you're going to have to teach yourself, and the book does it a little bit harder probably than I'm going to be doing it. And it won't bring up the little things that I'm going to have on the test that you guys should know about. So make sure you're at class these next 4 classes today and the next 3 after this. They're really important. The final is May 21st at 1:30, 5:30, and 7:30. It's a 2-hour final, but I was thinking, because I need to add at least half an hour anyways for, to give you guys time to input the answers and to scan the room and stuff like that and look it up. But I was thinking maybe I'll just give you guys 3 hours. That way you guys can not be stressed about it and have plenty of time and not feel rushed. If everybody's okay with that. If there are no conflicts with you with another class, if you can take one of these times and that works well for you. If not, let me know. Let me know if there's a conflict, and maybe I'll just do a 2.5-hour exam. But I think, if possible, if you can just, it should be fair to everybody, though, that's the thing. So hopefully a 3-hour exam fits okay with your schedule. Just, either email me if you have a problem or private message me. Okay, but this is what I'm planning on doing. It's just, that way they don't overlap. So 1:30 to 4:30, and then yours will be 4:30 to 7:30, and then the night classes will be 7:30 to 10:30. And again, I don't think it's going to take people that much time. Like, you guys did not use all the time that you needed. I think for the exam 2, most of you. So, I think it'll be fine. The other thing is, generally speaking, you guys did really well on exam 2. It was, most of you got A's and B's for the most part. I haven't graded it all the way. I need to go through the actual exams themselves and make sure you showed all your work and check a couple of little things here and there that maybe you should get partial credit for. But if you are okay if I just look through them quickly like that, instead of bringing them up in my tablet and writing on them all to give you feedback, then I can get them graded, exam 2 graded by like Friday or Saturday at the latest. So if you're okay with me not writing on it and giving you feedback, then I can get those graded super quick. Exam 3 is going to take me a lot longer because I have to look at each of them, pull up my writing file for you, and then pull up your picture file and then make a copy of it and write on it and everything else. So that's going to probably take me at least until Tuesday to finish up exam 3. But are you guys okay if I just, okay, good. All right, I'll just go ahead and get you guys your grades. And then later on, I will let you know how many points you got for each class. Hold on a second. I'll let you know how many points you had for each question, so then you know which question you got wrong, and you can kind of come to me and talk to me during office hours and say, hey, how did I solve this right, or what should I do before the final and stuff like that. Yeah, question? Go ahead.
So the part of you going back and looking at comparing the answers versus the computer use, just to see if little details of where we would, gain an extra point or whatnot. Is that part of your feedback, or is that separate?
No. That's stuff. I have to do that. That's part of the grading. The feedback is when I write on your test, I circle what's wrong, and I write, like, rounding error or whatever, stuff like that. So that's the feedback. I won't write on any of them. I'll just go through them and figure out. And I also have to go through and make sure that all you guys have, shown all your work. Because if you just gave me the answer and didn't show any work, then you're not going to get all your points either. So just, kind of making sure people have shown their work and to see if people get partial credit for those last problems, stuff like that.
Okay.
All right. Good deal. Perfect. So let's go ahead and take a look at a couple other things. So first of all, some of you have not signed up for the second part of the exam, right? So 30% of your exam is you checking in with me for 10 minutes and me asking you a couple of questions that are, similar to stuff you need that are from that study guide, the Exam 2 study guide. Those questions I said you should focus on for the Exam 2 study guide, same questions. They're not any different than that. So some of you guys have not signed up for that yet, so make sure you go to exam information in Canvas, and then from there, this is the first thing that comes up there is in their exam information is this link there. So you click on that link, they'll bring you to the sheet to sign up for, and just type your name in here. This is the link for Zoom. It's right in here as well. It's my regular office hour link. So, but it's also typed in there, and sign up for your spot. And try to come in, a couple minutes early, and you'll be in the waiting room, and I'll let you in when I'm ready for you. But that would be great. Good. Questions? No questions? We already went through the exam, or the agenda. Yes. Okay, so maybe we'll do this one here. Rizzo, go ahead and read. The top part too. Don't forget the title. That's important. The focus.
Focus for 3 more weeks. You have worked hard. Don't blow it now. Final is 26% of your grade. Keep up homework, which is 14%. In-class quiz and labs are 14%. Test lab is 7%. Each exam, 13%. Final, 26%. Grade is calculated as a weighted mean, similar to probability distribution or GPA. Example, online homework is 60%. In-class quiz is 80, test lab 75, exam 1 90, exam 2 50, exam 3 60. Okay. What am I getting now?
Well, no, thank you. Perfect. So yeah, so if these are your grades, right? You have a 60 in your online homework, you have an 80 in your in-class quizzes, you have a 75% in your tech labs. Then this 75% has a weight of 7%. That's how much of your grade it's worth. This 80 has a weight of 14. This 60 has a weight of 14%, 0.14. This 90 has a weight of 0.13. Each of these have a weight of 13%. So if you wanted to, this is just a weighted mean is all it is, right? So kind of think about it, each one of them. This 60, right, your homework, that has a weight of 14. This in-class quiz grade has a weight of 14. Your tech lab has a weight of 7. Sorry about that. And exam 1, 90 has a weight of 13. Exam 2, a weight of 13. 60, a weight of 13. And then my final has a weight of 0.26. I don't know what my final is. I want to figure out what I want to get. So what you're going to do is you're going to do a weighted mean, right? You're going to multiply every value by its weight and add them up. So I'll do 60 times 0.14 plus 80 times 0.14 plus 75 times 0.07. Make sure it's 07, right? 7 cents, not 0.7. That'd be 70%. And you're going to add all them up, and you'll end up getting 5 50.85 plus the last one, 0.26 times x. So you have 0.26x plus 50.85, and then set that equal to your goal, whatever it is. This person's goal was to pass with a 70, but yours could be 80 or 90 depending on what you want to get. And then subtract. How do you solve this? You're going to subtract this from both sides. So I subtract 50.85 from both sides. I'll get 0.26x equals 70 minus 50.85. Oops. Try that again. 70 minus 50.85. And then you're going to divide both sides by 0.26 to find what x is, divided by 0.26. So that means I'm going to need to get 73.65 on the final in order to get a C in the class, in order to pass the class. So that's kind of how you work it out. And again, you can do that for yourself to figure out what you need to get in the final in order to pass. But this is just a weighted mean, this top part up here, right? Every value multiplied by its weight. The weight or the frequency are the things that don't change. The things that vary are your grades over here, the scores over here. So the weight or the frequencies, the things you divide by, that you divide by the sum of the frequencies, the sum of the weights, those are the things that don't change, that are fixed. Okay.
Professor?
Yes.
How do we figure out our in-class quiz grade and our online homework grade?
If you go to Connect Math, it should be in there under, if you go to Connect Math in your grade book, it should give each section separately, doesn't it? Does it not do that? Does it not give you, you should be able to select just your in-class quizzes and it should give you a grade for just those. And each one of the pieces. I'm a little bit late on getting those in. I think I only have until, I think I might have put in until we stopped. But I think I did not put anything in from, since we've been online. So I will have that, after I finish getting exam 3 graded, then I'll turn to that and get those knocked out. So that will probably be a little, you know, in a little over a week I should have those. Ask me next Tuesday and I'll remind me to focus on that.
Okay.
Cool. All right. So here are our Chapter 10 learning objectives. We covered the exam. We covered the final. Okay, I suppose this is good. So these are the things we're going to be doing for Chapter 10. You're going to draw a scatter plot for a set of ordered pairs. Learn how to compute the correlation coefficient. Learn how to test a hypothesis. And compute the equation of the regression line. So these are the things we're going to be focusing on today and doing. Angela, go ahead and read this one for me.
In addition to hypothesis testing and confidence intervals, inferential statistics involves determining whether a relationship between two or more numerical or quantitative variables exists.
Perfect. Thank you. So we're going to see whether or not relationships exist between. So, you know, hypothesis, we figured out if there's a difference between them. Right? Confidence intervals we use to estimate. But this part we're going to do is we're also, you know, it also concerns finding if there's a relationship or not between two variables. So we talked about, Chapter 9 was about, we compared two samples, but they're the same variable. You know, it was like your right arm versus your left arm blood pressure, or the height of a president and the height of his opponent. There's two samples, but there's still the same thing. There's still height. There's still both height, or there's still both blood pressure. These are going to be two totally different things, like cars and income. Completely different variables, different items completely. Not cars and cars, cars and income, right? So two separate things, two different variables. Correlation is going to be determining if a linear relationship develops between these two variables, and the regression describes what type of relationship it is, whether it's positive or negative, linear or nonlinear. So if you look at your Chapter 10 notes, this is the first part of the page. Right, so Chapter 10 notes look like this. It's a little bit wonky. So here it is, and we're going through this part right here. This is the first part of it. So these are our Chapter 10 notes. Okay. So these are the 4 questions we're going to ask. This is the first question here. Rosa, do you want to go and read this one?
Introduction. Can you hear me?
Yeah, go ahead.
Introduction. 1. Are 2 or more variables related? 2. If so, what is the strength of the relationship? To answer these 2 questions,
Statisticians? Statisticians, yeah.
Use the correlation. Use the correlation coefficient, a numerical measure to determine whether 2 or more variables are related, and to determine the strength of the relationship between or among the variables.
Right. So we're going to be finding the correlation coefficient. That's the kind of the big thing we're going to be doing today. Laurel, go ahead and read this one.
Introduction. What types of relationships is best? There are 2 types of relationships, a simple and multiple. In a simple relationship, there are 2 variables, an independent variable, predictor variable, and a dependent variable, response variable. In a multiple relationship, there are 2 or more independent variables that are used to predict one dependent variable.
Perfect, thank you. Right, so remember from Chapter 2, we had our independent variable, the one we can mess with, the one we can control, right? That's our x value. And we had our dependent variable, the one that we can't mess with and we have no control over. That's our y. And then there could be also a multiple relationship where there's 2 or more independent variables that are used to predict one dependent variable. So for example, with coronavirus, right, you'd have people's age. That's one variable. Another variable might be whether or not how severe if they have what their respiratory situation is, if they have a respiratory illness or not, and if they do, how extreme is it? Another one might be like their heart, if they have any heart problems, and if so, how extreme it is. And those variables are used to predict whether or not, the likelihood of them getting coronavirus if they're exposed to it, or, sorry, not getting coronavirus, but having a bad result if they were to get it. Let's have Austin go ahead and read this one.
What kind of predictions can be made from the relationship? Predictions are made daily in all areas. Examples include weather forecasting, stock market analysis, sales predictions, crop predictions, gasoline price prediction, and sports prediction. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between the variables, the more accurate the prediction is.
Great, thank you. Right. So, like they did a lot of predictions with coronavirus, right? Kind of figuring out, how many deaths will we have if we don't do anything and we don't change things based upon how things are growing and how much the infection is spreading and other things like that. And that was not a linear prediction. Those are not linear. If you guys remember, they talked about logarithmic. They're using logarithmic tables. It was growing logarithmically, exponentially. So that's not linear. We're going to be dealing with linear, which is a much simpler, more straightforward form of it. Yeah, and ideally, once you make a prediction, then you can try to take steps to try to change that prediction or make changes to make that not happen. So first we're going to be doing scatter plots. It's a graph of the ordered pairs, x comma y, of numbers consisting of the independent variable x and the dependent variable y. So we'll be looking at those. I think I should move this over a little bit. Great. So we'll be looking at those 2 things there. Again, x is your independent variable, y is your dependent variable. So here's our first example. I'm going to construct a scatter plot for the data shown below for car rental companies in the United States for recent years. So we have, here's a company, and this is how many cars they have in 10,000s, how many tens of thousands of cars they have, and the revenue in billions. So which one can I control more? How many cars I have or how much money I make, my revenue? Which one do I have more control over?
How many cars you have?
Yep, how many cars I have. So that is my independent variable, that's my X, right? And then my dependent variable would be revenue, that'd be my Y. So here's, this one company had 63.0 for cars and 7.0 for billions, so that point would be 63.0 comma 7.0. That's the point that represents this company. So, draw and label the x-axis. So the x-axis should go from 8.5 to 63.0. It should cover that range. The y's, they're dependent. Remember that whole misleading graph stuff? So this really should start at 0. Otherwise it's misleading, and go up to 7. So here it is. And you'll notice it goes from 6.5 up to 63. It covers that range. And then it goes from 0 to 7, up to 7 at least. And it's labeled. Cars down here, right? And revenue over here. And this guy right here is that first one, company A. 63.0, comma 7.0. So you kind of see how it kind of matches up there. That's him, company A. And you can kind of see there's this positive relationship going on, right? Kind of a positive linear relationship. It kind of goes up along this line. So that's a positive relationship. Was that question? Or just commenting?
I have a question. Does it make a difference? Is it a misleading graph because they represented it in, the x-axis by 10,000, but they reduced the y-axis by billion? Does that make a difference?
No, it's okay, because this is in billions of dollars, and that's in 10,000s. As long as they're accurate about this and here, this and this. What would be inaccurate would be if they didn't start at 0, so it seemed like there's a lot bigger difference between them. So, because whether this is in billions or in whole dollars, it would just make this graph scrunched up more or shrunk down more. It wouldn't make it seem like one was twice as tall as the other one. Like this one here, let's take a look. Like this guy here, he's roughly half as much as this one here, maybe. Is that you guys, or more likely, this one here is probably half as much as what this one is. Would you guys kind of agree? This guy's half as tall as he is. So this one, what is that, 20 comma something should be half as much as that guy there. Let's take a look back as the 31. Didn't do anything. Okay, so this guy should be half as much as this guy. And it is about, see this is 2.1, and he's about half of this guy. He's 3.9, so he's about 2, he's about 4. So he is about half as much as the other guy. So that's, all right, all it does, that scale of on the outside, all it does is stretch or shrink your graph a little bit. It'll still, the proportions still stay the same, if that makes any sense. So that was a good question. Thanks for asking that. All right, so you guys are going to construct a scatter plot of your own for the data in this study. So here we have absences and we have final grades. What do you think you have more control over? The number of absences you have or your final grade?
Absences.
Absences, yeah. So that's going to be your X value, your independent value variable. So absences is X, our independent variable, and then our final grade is Y, our dependent variable. So you're going to graph these on an axis. So our X needs to go at least from 2 to 15. So I would say along here, I would just go by 5s, 0, 5, 10, 15 along the bottom. And label it. You have to label it. What is it? It's absences. And then your Y's along here should start at 0 and should go up to 90. So here I'd go in 10s, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then go ahead and graph out your points. So go ahead and do that now. I'll give you guys just a couple minutes to do that. I'll try to work on your breakout rooms and get those set up. Actually, Rosie, I'm going to stick you in a different room because I think we have too many people in that room. So I'm going to put you somewhere else. Sterling's here. Okay. Sterling and Eduardo, they have their room. Actually, let's have a smattering of people left. I'm going to put you guys all into your own room. So Jocelyn and Rosie, Ruby and Sonia from the other class. I'll put you guys into a different room. And I don't think you guys need it for this one because I think we're just about... Oh, Jocelyn's already in a room.
Professor, on each point, do we need to label like student A, B, C, etc.?
Nope, you don't. You do not. But you do need to label absences and final grade. So you guys need just another minute. Everybody good? If you want, I can throw you into a breakout room for 60 seconds or 90 seconds if you guys need. But I think this one's fairly straightforward. Okay, so let's take a look and see what we've got here. Yours should look something like this. All right, you've got, you probably have 0, 5, 10, and 15 along the bottom, and then it should just start at 0 and up to 90 here. And you have these dots looking something like this. So you can see it kind of makes this negative relationship downward, right? It's kind of like a line going downwards. Good?
Oh, Professor, one more thing.
Yeah, totally.
On an exam, do you want us to draw the line through and say whether it's positive or negative relationship?
No, that's okay. This is just visual for you guys to get a sense of negative relationship goes like this. So you do not have to do that. Okay. So here's another example. Right. Amanda, go ahead and read. Or if Amanda can't, Sonia, go ahead and read.
Example 2, age and wealth. A researcher wishes to see if there is a relationship between the ages of the wealthiest people in the world and their net worth. The data shows a random sample of 10 persons selected from the Forbes list of the 400 richest people for a recent year. Step 1, draw and label the X and Y.
Yep, perfect. Thank you.
That's just one each point. Sorry.
That's okay. That's all good. Perfect. So yeah, so there's gonna, again, they need to cover, make sure they cover from X from 38 to 83. They have to cover that range. And the Y should go from 0 up to the maximum of 69. So this is them doing that one. right? So age along here, wealth along there, and you can see there's no relationship. It doesn't make any sort of linear line or any sort of real sort of curve in any way. So this is we call no relationship at all. So this is no relationship. And then you'll see, you saw this one, which is the positive relationship, right? It's going up like that. And then you also saw the negative relationship going down like this. All right, so now we're going to talk about, I'm going to talk to you about rho. So RHO, 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 the Greek letter rho, so it's kind of like the Greek letter R, I guess. It's this loopy thing here. So you just kind of do a sort of a loop around, it's up and around. It doesn't have a little notch like a P. It's just a curve. It kind of curves up, swirls around. So this is a rho. It looks kind of like a P, but it's not a P. It's rho. Curls around. All right, so Gina, can you go and read this one for us?
Okay, the linear correlation coefficient denoted by a rho is computed from the sample data and measures the strength and direction of the linear relationship between two quantitative variables. The one explained in this section is called the Pearson product moment correlation coefficient, PPMC.
You skipped the top part. Read the top part too.
Okay, the population correlation coefficient denoted by rho is computed by using all possible pairs of data values x, y taken from a population.
Perfect. So rho is for the population. The R, just regular ordinary letter R, is for the sample. Remember, all samples always have regular ordinary letters, and population ones always have these weird Greek letters. So population correlation coefficient is rho. That's the thing we're always trying to find. The thing we have from our sample is R. These are the correlation coefficients for a sample and for a population. The range of the correlation coefficient. Why am I reading this? Derek, go ahead and read. Okay, not Derek. Haley?
Correlation, the range of the correlation coefficient is from -1 to 1. If there is a strong positive linear relationship between the variables, the value of R will be close to 1, positive 1.
Mm-hmm.
If there are a strong negative linear relationship between the variables, the value of R will be close to -1.
Exactly. So strong positive linear relationship, it means it's very much like a line, a perfect line. So it looks sort of like a line here. If your data forms a perfect line, then it would have a linear relationship, positive linear relationship, and the maximum. So the range is from -1 to +1, where these are perfect lines. So +1 would be a perfect line with a positive slope. -1 would be a perfect line with a negative slope. And then, if it's not a line at all, if it's a big jumbled mess of dots with no direction at all, then it would have a 0 correlation coefficient. No relationship at all, no linear relationship at all. And I kind of like it because they sort of look like they are, right? 1, it looks like a line. 1 over here, even though it's negative on the negative side, also looks like a line. And 0, a correlation coefficient of 0 looks like a circle. It's just a big circle with a bunch of dots in kind of a circular, just kind of randomly, right? Just a whole big jumble of dots with no direction whatsoever. So that is kind of useful. So I'm going to let you guys. Yeah, go ahead.
So a negative linear relationship is so it's not a full line, like positive, it's just kind of like a half line, a small line.
No. Let me let me show you as I'm talking about here. Oops, speaker view. Okay, so imagine I go to the store and I buy muffins, right? For every muffin that I buy, if I look at how much money I'm spending, if I buy one muffin I spend $3. If I buy 2 muffins, I spend $6. If I buy 3 muffins, I spend $9. It makes this perfect line, right? The more muffins I buy, the more money I spend. It's a perfect linear correlation, and it's a perfect line. I know exactly, I can predict exactly how much it's going to cost me for 5 muffins. Right? It's a perfect line. That would be, and it's positive, right? Because as my muffins go up, my cost goes up. If I was looking at how much money I have in my pocket when I spend these muffins, then that's a perfect linear relationship down. For every muffin I buy, I lose $3. If I buy 2 muffins, I lose $6. So that makes this perfect linear relationship downward. It doesn't matter what the slope is, it's just that it's going downward in some way on a perfect line. So I can predict how much money I'll lose if I buy 3 muffins. I know I'm going to lose $9 because that's how much money I will have spent. So it has a perfect linear correlation, like buying muffins. Then it would have a linear correlation of 1 because it makes a perfect line. Does that make more sense now, or did that answer your question, or do you still have a question?
Yes, that answered it. Thank you.
Okay, cool. Awesome. Very good. All right, so what I need you guys to do now is turn the page. Yeah, so you should have filled in the bottom part already, right? The bottom of page 1, the first page. Hopefully you filled that in from this information here. And then flip the page, and you need to figure out which one of those pictures matches up with which one of those numbers. So I'm going to put you guys in your breakout rooms. Go ahead and take a look at it if you need to.